understanding how red seaweed reduces methane emissions from cows. This is by Eric Moser, University of Pennsylvania. Methane is the second largest contributor to climate warming after carbon dioxide, and so scientists have put a lot of attention towards addressing one of the top sources, methane emissions from livestock. In other words, cow burps are bad for the planet, or cow farts. Now, farmers add various seaweeds to cow diets as a source of protein, unsaturated fats, and other health-promoting ingredients that provide immediate energy, says Dipti Pita of the University of Pennsylvania School of Veterinary Medicine. And a 2016 study in Australia found that feeding sheep a species of red seaweed called Asparagopsis taxiformis, AT for short, eliminated methane emission by a whopping 80%, 80. But the effects of this seaweed vary widely, and so researchers from PETA's Agricultural System and Microbial Genomics Laboratory, ASMG Lab, and Pennsylvania State University undertook an assessment of how it alters the microbiome in the rumen, a compartment of the cow's stomach. The results are published in the journal MBio. The researchers randomly split 20 cows between 4 treatments, a high dose of AT, a low dose of this red seaweed, oregano, which also inhibits methane formation, and the control group. They rotated the animals among the treatments in 4 28-day periods. The team found that the high dose of seaweed inhibited methane emission by 55% in the first 2 periods, but the effect appears short-lived. It gradually declined by the 3rd and 4th periods. PETA says that is one of the first studies examined how methane is formed in the rumen and how methane pathways are altered under various mitigation strategies, noting the importance of preserving microbiome health and animal productivity when addressing methane production. Past research has not looked at the effects of AT on microbial populations and their functional pathways in this level of detail. The researchers found that in the first 2 28-day periods, the high dose of seaweed led to a near total elimination of Methanosphera, a microbe that uses hydrogen to reduce methanol to methane in the rumen. PETA says that this is important because the seaweed treatment did not have the same effect on other microbiomes, on other microbes that produce methane, leading researchers to believe that Methanosphera plays a larger role in methane formation than previously thought. However, the study explains that Methanosphera populations spiked in later periods because they were unable to inactivate bromoform, a substance in seaweeds that suppresses the formation of methane in the rumen. The study also explored the activity of enzymes involved in methanogenesis, the process of producing methane as a byproduct of energy metabolism. The first author, Nagarayu Indugu, a senior research investigator in the ASMG lab, says the enzymes involved in this pathway were reduced compared to the control group when the cows were given AT. The authors also noted that while they expected indirect effects of AT on bacteria in the microbiota, they also found direct effects that were less expected. Specifically, the types of bacteria that produce butyrate, a short-chainy fatty acid serving as an energy source for cows, were significantly increased in seaweed-treated animals compared to the control group. It's very important to understand that the nutrient content of seaweed is and what the antimicrobial effects of seaweeds are, so that we better understand the impact of the overall inclusion of different concentrations of seaweed on the animal diet, PETA says. Indugu says the past work of the ASMG lab led to the current study. Researchers previously reported that the organic compound 3-nitrooxypropanol reduced methane emissions by 26%, and a subsequent study determined the microbial characteristics of low methane emitted cows. Looking ahead, PETA says the lab is working on combining different strategies, such as testing seaweed in the diets of cows that have been identified as high methane emitters or low methane emitters, Combining those with the seaweed might give us an opportunity to effectively reduce methane by a much higher magnitude than when you do any one strategy alone, she says. PETA adds that researchers are also investigating different doses of seaweed varieties and methanogenic cultures, which will provide a more specificity on the concentrations necessary to inhibit methanogenesis, production of methane, that is. This is by University of Pennsylvania. Erica Moser on phys.org. Please leave your comments and thank you for your support. Finally, support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.